Hello everyone, welcome to dadi image service for container clusters. This is a working system deployed at scale in Alibaba and published at ATC20. I am Lanzheng Liu, one of the authors. This is a sample presentation. Containers are becoming the foundation of cloud platform, especially for cloud-native applications. But deploying containers involves a lot of time. Sometimes the long-tail latency reaches tens of minutes. dadi image service is trying to solve this very problem. The essential regions are image downloading and unpacking. They are both very slow, but the point is, only 6.4% of image is actually used, according to a previous research. To some extent, it is a regression to a decade ago, when virtual machine images were also downloaded to the hosts. P2P downloading is widely used in large clusters. It significantly improved downloading speed in these environments, but results are still far from satisfactory, as it deals with only half the reason. The actions of downloading and unpacking are still there. Furthermore, P2P downloading has little effect for small clusters. Slimming the image is another attempt to improve deploying latency, but this approach is not universal, because it's hard to automatically find all dependencies for all applications, and it's also hard to support ad hoc operations within containers. And we believe the ideal approach is the remote image format that avoids the beforehand downloading and unpacking. Furthermore, we need P2P transfer for large clusters to cope with the scalability problem. But the fact is, the turbo normal image format is not viable for remote image, as it's not seekable. The format was designed for entirely unpacking, so it is a must to change the format, and we believe it's better to design a new one. There are two types of images. One is file system based, and the other is block device based. Choosing a proper type of image is quite important, because it influences a lot of things. Let's see a comparison between the two technology roads. A file system based remote image provides a file system interface directly to containers. It is a natural extension of container image, so it incurs less metal friction. A block device-based remote image usually works together with a regular file system, such as ext4 XFS, so as to get fully POSIX complete. And the block device can be easily integrated with container, secure container, and virtual machine. A file system-based remote image more complex, as the file system interface involves many operations that have complex semantics. So, it is more difficult to get stable, more difficult to apply optimizations, and more difficult to develop advanced features such as extended attribute or cross-reference. A block device-based remote image, on the other hand, is much simpler. So it is easier to get stable, easier to get optimizations, and easier to develop advanced features. A block device-based remote image is more universal, because it allows applications to choose the best fit file system. For example, a Windows container running on Linux host may choose NTFS as its image file system. A block-based remote image has smaller attack interface, so it's easier to get secure. According to this analysis, we base dadi image service on block device, although we are working almost there. We believe this is the best approach for container system. Now let's take a look at the background. Container images are downloaded to hosts and unpacked there. An image contains multiple layers. Each layer is a change set compared to the previous state, namely file added, modified, and deleted. The layers are read-only and shared by multiple container instances. Each instance has a private container layer that is a change set compared to the image. Usually, the layers are stored in separate directories, and the merged view is created with a kernel module called overlay.fs. This is L path of image. Containers send L requests to the kernel overlay.fs and redirect to corresponding layer, which is stored in local.fs. There are three core components of dadi. The first is the novel layers image format based on virtual block device. Each layer is a collection of modified data blocks under the file system. dadi provides a merged view of the layers by a module called overlay block device, or overlay BD for short. This is a general solution for container ecosystem. The second is a compression file format called Z-file, which supports seekable online decompression. The third one is a tree structure P2P system, providing on-demand transfer in large-scale cluster. That's it. Thank you.